This is FET316 technology element. When the IP address and subnet mask of a PC are shown below, which of the following is the appropriate network address of this PC? So for the PC, the IP address is 200.170.70.19, and the subnet mask is 255.255.255.240. So which one is the appropriate network address of this PC? 200.170.70.0, 200.170.70.31, 200.170.70.16, or finally D, 200.170.70.255. So let's have a look at network addresses and IP addresses to see if we can get any closer to the answer for the question on the previous slide. So first of all, network address is any logical or physical address that uniquely distinguishes a network node or a device over a computer or telecommunications network. An IP address or an Internet Protocol address is an address used in order to uniquely identify a device on an IP network. The address is made up of 32 binary bits, which can be divisible into a network portion and a host portion with the help of the subnet mask. The 32 binary bits are broken into 4 octets. 1 octet is equal to 8 bits. Each octet is converted to a decimal and separated by a period or a dot. The value in each octet ranges from 0 to 255 in decimal, or 8 zeros to 8 ones in binary. The subnet mask, a 32-bit combination used to describe which portion of an address refers to the subnet and which part refers to the host. An IP address in the section of a digit 1 in the subnet mask is the network part, and the section of digit 0 is the host part. Writing the IP address and the subnet mask of the 255.255.240 in a binary number and using the bitwise AND operation gives the following. So if we convert the IP address we were given here into binary and the subnet mask that we were given 255.255.255.240 into binary, we end up with this kind of mask. By using a bitwise AND, we get rid of the parts which refer to the host and only are left with the network part. So here the network address is this. It's the same for where all the ones in the subnet mask occur, but after this they become 0. The bitwise AND operator returns 1 in each bit position if both corresponding bits are 1, otherwise it returns a 0. The resultant network address is this. In binary, each octet is separated by a dot, as we said on the previous slide. Converting this back into the format of an IPv4 address gives 200.170.70.16. So this is our network address. So the AND operation on the IP address and the subnet mask gives the network address. In addition, in the case of the subnet mask, only the last 8 bits are required to be calculated. Therefore C is the correct answer. As we said, C is our correct answer. In this video we've learnt more about addressing, especially IP addresses, and how we can use a subnet mask to retrieve the network part of the IP address from the overall IP.